Thank you very much for Friday afternoon and then come for the seminar. And then it's my honor to welcome a professor from Taiwan University of Science and Technology, fly all the way from Taiwan, and Professor Poki Chen. And let me just read a little bit of a brief introduction of him. He served as an associate editor for IEEE transactions on a very large scale integration system since 2011, and IEEE Access since 2013. He has been the organizer of IEEE International Conference on Intelligent Green Building and a Smart Grid since 2014. He served as a keynote and invited speaker, TPC member, session chair of various IEEE conferences, including SOCC, VLSI Day, and many other top-tier conferences. His research interests include analog and mixed signal, integrated circuit design and layout, with a special focus on time domain signal processing circuit, such as time domain intelligent temperature sensors, time to digital converters, digital pulse converters, time domain ADCs, and then high accuracy VACs. He's also interested in developing innovative analog applications for FPGA platforms such as FPGA, intelligent temperature sensors, digital to time converter, and time to digital converters. So, let's not waste more time. Please welcome our speaker, Dr. Chen.
Thank you so much. You saved my life. Actually, I
also need to thank you, Dr. Jose, for organizing this.
Yeah, thank you, Jose. I know that our fields are far away, so no worries. I wouldn't like to torture anybody of you. I will try to make my talk as short as possible. Yeah, even though I am an analog IC designer, we design circuit, we design hardware. But anyway, nowadays I think everything runs on semiconductor. So never mind what kind of research you are doing. I think you need the fundamental checks, the AI chips, anything CPU, GPU, anything like that. So let's go further. Before my real talk, I would like to grasp the chance to introduce my own university. Yeah, I'm from National Taiwan University of Science and Technology, in brief, Taiwan Tech. We are the best technical university in Taiwan, and I think the campus size may be about the same as yours. However, your buildings are much more beautiful than ours. Anyway, congratulations. Yeah, you have very old style building, if I'm right. Yeah. So let's go further. For the moment.
The one you got showing looks good.
Oh, that is I think I said that is the newest, but the second newest. Yeah. So wait a moment.
Yeah.
Does it work?
No.
No, wait a moment. How to wait? How about the keyboard? Oh, this one. All right. Thank you again. So our location, is our university with the name of our own country. So definitely, we locate in the capital city, Taipei. And you can see, Taiwan is a small island. The length is around 400 kilometers, and the width, I think, yeah, maybe less than 100. That is what I think. All right, but even on such kind of small island, we have more than 200 peaks, higher than 3,000 meters. So even we belong to some kind of semi-tropical area, however, we still have snowing in winter. So we can enjoy snowing, hiking in the winter, Yeah, but anyway, maybe only for 1 or 2 months, good enough on high peaks. So you can see, if you would like to tour around the whole country from the seashore to the highest peak, we call it a Jade Mountain. Jade Mountain, the height is almost 4,000 meters. Yeah, by driving, I think you only take maybe 3 hours, then go hiking to the top peak. But it's very, very crowded. And then, oh, this is a very brief history about my own university. It is established almost 5 decades ago. So we had the fifth annual celebration maybe in last month, yeah, before my departure to USA. So you can see we are really young. I have no idea how old your university is.
127.
Oh, you are our big brother. Oh, yeah. So we renamed from some kind of institute to technical university. Until now, we are still the best technical university in Taiwan. And then some kind of facts and figures. According to the student body, I think we are of about the same size, right? We have only 11 something thousands. And according to our professors, I guess around 500 or something. Yeah. However, our campus may be a little bit smaller than yours. Anyway, anyhow, but the key figures, the number of international students on campus, we are the most. I mean, for international master and PhD students. So we are the most internationalized university in Taiwan. To the student body, the biggest one, I think, is our big brother, National Taiwan University. Yeah. And how many they have? If I'm right, 35,000 students. So according to the student body, they are around 3.5 times larger than us. And according to the faculty size, I guess they have more than 3,000. So they are around 6 times larger than us. And how about the performance? Sorry for that. I think they can achieve 6 times or even 3.5 times more, yeah, performance achievements than us. So according to many kind of international ranking, we were ranked around top 2 to top 5. Never mind according to QS or Times, THE. Yeah, anyway. So that is something for you to refer. And these are all. We have the NTU system. We have 3 sister universities in the system. And it means what? All those 3 universities locate in Taipei City, and by us, we can swap the campus for the students within 20 minutes. So we have a very interesting schedule for all the courses. In between the morning, in the middle of the morning and afternoon sections, we have 20 minutes. And we provide shuttle bus for students to swap campus. And it means all the students can enjoy the resources from any sister universities. So, and that is some kind of overview. We are small but ambitious. So, for example, we have the best design college or faculty in Taiwan because we were the first to create, to open the faculty. Until now, it is still the best. Okay, I think that is good enough. Briefly speaking, we are open to any kind of cooperation. Later I will explain. We have research cooperation. We have dual degree programs with many of the international sister universities. Hopefully, your university will be interested in our student exchange, anything. Yeah. So allow me to swap to my real talk. So yeah, I would like to talk something about programming instead of circuit design. Yeah, but it is related to circuit design. How to enhance, how to optimize the circuit performance by coding. That is what I would like to talk today. Thank for Professor Ray to have a very good and brief introduction about myself. So let's go further. Oh, yeah, that is what I would like to encourage my students to join my research or join the whole semiconductor industry. Yeah, you can see that is the humankind revolution in the past. We have some wrong technology. Yeah, our ancestors stood up and then bend it down for typing, right? So hopefully we will have good enough new technology, new evolution to help all humankind stand up. And what is that? Guess what? Okay, very simple. Nowadays, everybody use it. So again, semiconductor helps a lot, helps our modern lives. And if we take the chips away from our daily lives, what will happen? Let's go back to Stone Age. That's it. So semiconductor is really, really important, not only for Taiwan, for USA, for almost all the countries on Earth. And why semiconductor? Because just for the recent days, there is some kind of tsunami for the stock market, right? According to the USA-China trade war. Yeah, anyway, that is the key reason for the economy tsunami. So you can see that is the cause for such kind of trade war. It is really important. And allow me to, your president, Donald Trump, say that we Taiwanese stole the semiconductor from your country? Oh, no, no. It's not true. Why? Because according to the history of our semiconductor development, you can see we worked very, very hard. We learned, yeah, to be honest, we learned everything from American. But we try to enhance the performance, the yield, everything. That is what history can teach us. So you can see from the very beginning, we were nobody. Almost nobody paid any attention to Taiwan because Taiwan is so small, right? Maybe many of you didn't visit Taiwan, or you guys don't need to learn international history, right? Anyway, anyhow, yeah, you can see from the very beginning how long ago, more than 5 decades, right? We are before that, Chiang Kai-shek was defeated by Red China, so he ran for his life. He ran for his life to Taiwan along with many of the soldiers. But from the very beginning, we didn't have any kind of good industry. So we tried to import a lot of bananas, pineapples to Japan, to maybe some to America to make a little money. Yeah. So never mind how hard we work, we only make a penny. Yeah. So our government would like to improve the lives of Taiwanese. So, but they didn't have any idea what they could do. They tried to contact somebody here, and we were really lucky. Dr. Pan was the first key person to contact. He's really passionate. If I'm right, he only stayed in Taiwan for a few years and then migrated along with his families here. But he's still passionate for Taiwan, for Taiwanese government. So he would like to help. And he worked for ASEAN, maybe as a vice president or something like that. But he was so passionate After some time, he told his wife he needed to quit his job from RCA because he needed to fly here and there between USA and Taiwan. It didn't make any sense. So he pleased his wife, let him go. Right. That is a big sacrifice. But anyway, anyhow, what we can do? He recommended our government to buy a fabrication line, which would be retired or be phased out very soon because RCA didn't have the capability to defeat Intel, Motorola, blah blah blah. Many of the top IC companies here. So RCA made the decision to phase out the whole production line, and we were really lucky. According to Dr. Pan, we bought the fabrication line from RCA, but in that era, we didn't know what is semiconductor. So we sent a lot of young people to Silicon Valley to learn everything from the RCA engineers, because we don't learn anything from microelectronics in that era. So what we can do, the young guys, they use some kind of stopwatch, yeah, to monitor, to measure how long for each step it should take, anything for all those details. So finally, we learn everything. Then we duplicate. We bought the fabrication line. We measure the directions, the orientations, the distance, space, and anything. Then we duplicate the whole system from Silicon Valley to Taiwan. So that is the first. You can see we open the demo site in Yizhi Institute. Anyway, yeah, that is the biggest research institute in Taiwan. We enhanced the yield from RCA from 17% to 70%. So that is a big number. And please pay attention to this. 70%, that is a magic number. If I'm right, for nowadays, 3 nanometer process, TSMC made it for 70% and then go for mass production. That is the key figure from the very beginning till now. Even till now, for example, for the newest 2 nanometers, a few months ago, TSMC announced they made it for 60, but it's still not ready for mass production. Luckily enough, right now, it is already 80% for 2 nanometer processes. So TSMC will launch the mass production maybe a few months later. Okay, and how about the Samsung, the same 2 nanometer process? I heard it in this morning. It is around 40%. And for the year, TSMC already makes it, yeah, 80. So that is a big difference. We opened the first company called United Manufacturing Company in Taiwan. We made a big success because we duplicated the whole system from America to Taiwan. And years later, we are even more luckier to invited Maurice Zhang. Yeah, Maurice Zhang, after Chiang Kai-shek lost the mainland China, Maurice Zhang's family went to Hong Kong for only a few years, then migrated to Taiwan, and also for only a few years. And after that, the whole family came here. Yeah. So you can see, Maurice only stayed in Taiwan for 2 or 3 years when he was really young. But when our government contacted him, he would like to sacrifice again, just like Dr. Pan. He retired from TI. In that era, he was already the vice president of TI, one of the vice presidents of TI. But he would like to work for Taiwan. He would like to replicate the same idea. In that era, we had only IDM, integrated device manufacturer IC companies. It means what? All the companies designed, fabricated, and sold all the chips by themselves, including UMC, the same. Morrison wouldn't like to be a copycat. So what he could do, he sold for almost 2 years, then created a new business model for the whole industry. So he would like to fabricate the chip only. He wouldn't like to sell any chip, to design any chip, no. Fabrication only company. TSMC was the first, until now is still the best on earth. It dominates the whole market. If I'm right, in last year, maybe the market share is around 65 or something. You can see a single company own the whole market, maybe around 2/3. That is fantastic. We are really lucky because through their help, we make something from nothing. I can't say from zero to hero, but at least we became somebody in this industry. But without their help, we are still nobody. Yeah, anyway, anyhow. So after years, after decades of struggling, hard working, finally, in 2021, we became the top one in IC fabrication, packaging, and testing. Top 2 in IC design. And how about the future? Who knows? But anyway, to say, we never steal anything from USA. No. But we would like to help. You can see all the top companies, NVIDIA, Apple, Facebook, even Tesla, they have their chips fabricated by TSMC. In this way, American companies are able to dominate the whole global markets for AI, for car driving, for anything. So I explained already. Okay, and then the other issue is according to shipping. You can see almost 88, around 90%, the largest container ships passing through Taiwan Strait. So you can see how dangerous it will be if China take Taiwan. Then all the commercial ships will stop if China is unhappy. Okay. But anyway, anyhow, that is really dangerous for democratic world. And why NTUST? Yeah, we are the most internationalized university in Taiwan, so please do cooperate with us for student exchange, dual degree, or research cooperation, anything, anyway. Okay. And why me? Yeah, because under the service, I push many of the research cooperation with UI, a University of Indonesia. That is the top 1 university in Indonesia because with the name of the country, right? And then ITB, the best technical university in Indonesia. Then ITS, the second best. CTU, the best technical university in Czech Republic. And Warsaw University of Technology, the best in Poland, blah, blah, blah. So hopefully SDSU will become the next. Hopefully. Yeah. And why I'm here, not for the talk, not for the cooperation only. I am a passionate tourist. Yes, this is the main reason I'm here. So I got the honoris causa from CTU, and then I went to the seashore to see your sea dogs, sea lions. Oh, actually, in the past, I had no idea what's the difference between C lines, C dots? I thought they are the same. No, sorry for that. When I went to the seashore, I read the signs over there. Oh, I totally understood what's the difference. Thank you for that. And then me and my families, where is that? Anybody? Has any idea?
Cardiff?
Ace Canyon.
Exactly. Yes. We love it very much. Yeah.
Right
Yeah.
off the freeway.
Actually, we would also like to hike into the potato chips rocks, but we already, it's a pity of us, we didn't have enough time. Anyway, right now, my families are in Las Vegas for gambling. No. Oh, that is fantastic. And there it's snowing. Beautiful, very beautiful. And that is double arch inside the Arches National Park. I love it very much. Okay, it's done. Oh no, 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 no. So to tell something about the research. According to IC design, we have two major kinds, analog one and digital one. Okay, to the left or to the right, as you like. Again, I need to point out that we Taiwanese work much harder and make much less than you guys. So please don't complain. Yeah, we Taiwanese, we can almost work from the day till night, not only for the engineers, but also for our students. Yeah, my students, they work till very late night. So this is the reason why I still, I still am a night owl. So I went to sleep maybe in this early morning, maybe around 2 a.m. So I woke up around 9. Yeah, anyway, anyhow, that is our very terrible life. Yeah, anyway, so let's go further. That's all right. So our software, our hardware, digital or analog, left or right, it is up to you. Okay, but nowadays I think we face the big challenge from AI. If we don't select the right way for our own futures, we may be replaced, especially the young guys. You may be replaced by AI. So don't go the wrong way because you will become life or death for your own future. Okay. Anyway, anyhow, that is what I'm telling my students locally or internationally. As you design, you will see our students need to work very, very hard. Why? Because we need to fine tune many of the parameters. It's really troublesome and boring because I will show you one of the examples, the circuit, and what we need to do. We need to fine tune the width, the length of the transistor. Yeah, anyway, if you guys don't know what is transistor, it's okay. For any of the devices on the chip in the circuit, my students need to fine tune the length, the width, and the bias. Usually we fine tune the bias current, something like that. Okay, that is troublesome. And it takes a long time. For example, for each new design in my lab, usually the students need maybe around 3 months for fine tuning. I mean for pre-simulation. And at the layout, we can do the post-simulation along with many of the parasitics. Then they may need another 6 months for fine tuning. And finally, if I think, oh, the result is good enough, they can apply for chip fabrication. Yeah, and after that, usually when they get the chip after measurement, the first reaction was wow, what? Really upset. It doesn't work at all. That is the usual case. Yeah. And usually the performance is not as good as expected. So that is our very miserable life. We need to redo it again and again. So it takes years. And how to speed up such kind of process? That is what I thought years ago. Yeah, we need to such kind of fine-tuning, time consuming, yeah, boring. So anyway, that is the wrong way for my students because they need to bend their bodies further. It doesn't make any sense. And we have many kind of challenges for such kind of IC design. We need to focus on many of the tiny issues. For example, we need to pay attention to the gain, the bandwidth, the speed, the power consumption, many of them. If you go for digital IC design, usually they only pay attention to the speed and power. That is good enough. Okay, but for us, sorry for that, we need to pay attention to many of the small issues. And that's the reason why it will take such a long time. So how, as a supervisor, but I can help? Actually, I was inspired by my own students. I have a team focusing on FPGA design. We don't design any kind of architecture, DPU, CPU. No. Yeah, we try to implement FPGA for analog applications. For example, we can design some FPGA circuit to sense the temperature, to measure the timing signal, how long the timing signal is, the width of the timing signal. We can generate the timing signal according to the digital input. And never mind for time measurement or generation. Nowadays, we can achieve 1 picosecond. Okay. Yeah, we are among only a few teams globally to achieve such kind of very fine resolution for time measurement or generation. Even for that kind of platform, to measure the circuit with such a very fine resolution, usually it takes weeks. Okay, it is very boring and tiresome. So a few years ago, some of my students, they try to automate the whole process. From the very beginning, they found some freeware called Eclipse. That is composed by Python or JSON. Anyway, yeah. So you can see that is the main target. Okay, allow me to show you the story. That is one of my poor students. From the very beginning, he needed to do everything by his own hands. Okay, so you can see he need to get key to type many of the parameters, to set the oscilloscope, to download the firmware into the on the FPGA board. So anyway, allow me to speed up. Yeah, after some time, he will become very sleepy. So what he could do anyway, he clicks. You can see after clicking the icon to stop the program, he didn't need to do anything. You can see he's the one filling the whole process for all of you, right? And how much time it will take? In the past, I mentioned already a few weeks, but with such kind of automatic measurement system, we can make it for a few hours, less than 1 day. So it's a big advance. All right. So you can see we can help each other. Even though we are hardware designers, we can get help from software engineers. So maybe it is some kind of software and hardware co-design, maybe something very similar to that. That is what I was inspired by my student. So that is the stage 2, right? But with secrets, it has a GUI, graphical user interface, to recognize all the icons on the screen. Actually, it takes a longer time. So the third stage is to control everything by coding, by script. That's it. To get rid of the GUI, to speed up the whole process. That is what I was inspired by my students. So I told my Indonesian PhD student, his background, he studied here maybe for his bachelor degree, okay? Yeah, and then went back to Indonesia to pursue his master's degree for computer science. That is what we can help each other. So I recommended him. His background was really weak for analog IC design, but he could help all the others to do such kind of optimization for circuit optimization. So after that, he made it along with his netmates. So now to show this, that is the final outcome. You can see for the measure time, it could be reduced maybe for almost 1 order. Okay, and we are improving such kind of optimization process even till now. So right now, my students can make it for only a few hours or less than 1 hour. That is a big advance. But we are not only talking, we are doing and verify the concept. So allow me to show you, yeah, for the stage 1, my students need such kind of hardworking, and hardworking. That's it, no more. Our life is much miserable than yours. Sorry for that. Sorry for my students. Yeah, so no good for health. And that is the key for stage 2 secrets. Some kind of GUI freeware. As you can see, it maybe please don't tease at my students because they are hardware engineers, right? They are not so good at coding. So from the beginning, they apply such kind of GUI freeware to help them do everything they need instead by their own hands. Good enough. And then through the help of my Indonesian PhD student, yeah, with computer science as his background, we achieve this. Okay, we can measure such kind of very fine time to digital converter. I mean to measure the signal with 1 picosecond in resolution. Okay, and you can see the error here is quite small. Yeah, then all the other, please.
If you're using, let's say, Python or JSON or something like that, are you also using, well, one question is, are you using Spice and MATLAB? or-
Yeah.
Okay,
It's spice.
and are you using any of the National Instruments software, LabVIEW?
No, we don't need.
Is it, you don't need it, or you just don't like the, the user interface?
Both. Because with such kind of commercial software, right? Software and hardware is expensive. And never mind, it is expensive or not, we need to pay for it. But with secrets, and all the we have online, we can get many of the toolboxes for many of the instruments for free. So my student make it both.
Did you ever use computer algebra systems? Because sometimes they do these types of things, like Mathematica, Maple, but also Sage. Sage Math, SAGE Math. It's the free open source.
From the very beginning, they apply mathematical or something like that. MATLAB, sorry, MATLAB.
Yeah.
But after such kind of auto measurement, actually they do everything with Python. Yeah. So we are lucky. We don't need to pay any penny for such kind of automatic system. And we would like to, oh, that is some kind of comparison, and even for digital to time converter. Yeah, allow me to show you this. We have two luxury equipment from T side, and this is this price, right? And you see, we can apply such kind of very low cost FPGA to achieve something comparable to such kind of luxury equipment. So you can see that is the power of automation. Yeah, anyway, I have no time, so allow me to go further. This is my next dream. Next dream, I hope my students can do the same thing for analog IC design. And then the students will enjoy their life better than before. They won't have enough time, yeah, to sleep, hopefully. We made it a few years ago. And from era, a few years ago, I already showed the photo on my slide, mask. But what I would like to say is, even though we are much poorer than this guy, but we still deserve a dream. We can do something instead of nothing. Okay, so I told my student, or even when I was invited by Indonesian, Indian, or Polish, Czech universities to have some kind of speech or talk, I always encourage the students, don't complain. Your university are not so good. You don't have enough resource to do any good research. No, that is not true. Even though we are not as rich as this guy, we preserve our own dreams. Okay, so anyhow, you can see that is the flow chart for my students to achieve such kind of automatic performance optimization for our analog circuit.
This is just a design tool, correct? Or is there fabrication and testing in the loop?
Oh, no, only in design phase. Yes. For testing, actually, that is the very beginning, automatic measurement system. That is what we made. So we reverse the whole process. And then you can see, it's what I would like to let you guys know. For each device, we need to find the width, the length, or even the bias current. That is boring. Okay. And then we can go further. We need to know the domain knowledge. So if you guys are good, you guys are supposed to be very good at coding, much better than my students. So we can cooperate with each other to speed up, to enhance the performance of the whole system. So I would like my PhD student to help his senior to optimize this oscillator automatically. You guys don't need to be bothered. Okay, that is the real schematic, the real circuit, but you don't need to be bothered. If you would like to cooperate with such kind of hardware engineers, you only need to know the domain knowledge. It will be good enough. Then you guys will be able to help them optimize the performance. Anyhow, allow me to show you. That is, according to SPICE, that is what my student needs to find too. The length, the width, the multiples, something like that. Okay? By your own hands, it will take months. But with such kind of coding, it will be reduced to a few days, I guess. Okay? So with Python and OHSPICE, that is the circuit simulator. And then my students don't need to do it. They don't need to type anything. So, allow me to show you the result Oh, very brief introduction. Can you hear? Just allow me to go for the. Actually, we got a project from one of the IC design houses, power IC design houses in Taiwan, yeah, for 2 million NT dollars. This piece of cake here. Okay, but in Taiwan, 2 million, I'm not talking about US dollars. You need to divide it by 30 something. You are equivalent to US dollars. Oh, just that. Maybe around in that era, maybe a few years ago, about 70,000 US dollars. This is a solid proof. Me and my students were really happy. Okay. But here, if some company would like to provide you only 70,000 US dollars for a project, I think it will become a humiliation.
No, I'll be happy.
Oh, yeah. Are you sure? It's a solid proof. We work much harder, make much less than you guys here. So, yeah, don't say we steal anything from America. No. We deserve it. We deserve it. Okay. Anyway, anyhow, I'm going to show you the final result. This is for the is done by my Indian student for a few months. He achieved for temperature coefficient. Anyway, the output parameter needs to be stabilized according to temperature variation. So to measure the temperature sensitivity, usually we apply such kind of temperature coefficient. The less, the better. Okay, so by my Indian students, with hard working for a few months, he could achieve something like 40 something ppm, right? But with the help of my Indonesian student, you can see we enhance the temperature sensitivity by almost 4 times. But we need to prove it. So after that, my students applied for chip application, and you can see that is the real chip, and this is the measured waveform, right? And you can see the final result for temperature coefficient is around 28 something. That is another way I need to highlight. What you see is never what you get for analog IC design. For you guys, 1 plus 1 definitely equals 2, but sorry for that. 1 plus 1 will never be 2 for analog IC design. Okay, as an analog IC designer, we need to accept some kind of, we need to tolerate some kind of error. Okay, our duty is to reduce the error to acceptable level. That's it. So you can see, I'm really happy. Please.
What is the metric here? Is it just the oscillation frequency?
Yes. The oscillation frequency according to temperature variations, we hope it will stabilize, right? So that is what we measure. We compare with each other. So you can see, oh, that is the microphoto. For good IC design journals, without microphoto of the chips, without the real measurement, no application possibility. Okay, this is our very miserable life. Again, for you guys, what you see is what you get, but for us, it's never with that. Okay, and then we compare with the prior arts. You can see we achieve the smallest chip area again through such kind of automatic optimization. And then, according to figure of merit, we are among the best, or even the best for FOM2. So I was quite happy, and we published the paper. on actually probably transactions on VLSI system, something like that. Okay, maybe top 3 or top 4 IC design joiners. Anyway, we go for the other one, but time's up. I think, I had better. Okay, here. Yeah. Why such kind of software and hardware co-design is hard because we need such kind of multidisciplinary knowledge, right? Hardware and software co-design. In the past, we only focus on micro hard, such kind of circuit hardware with micro skill. Right now, it is already becomes narrow hard, right? With nanometer in process. But you can see we train our students from I shape to T shape, and right now they need to become com shape. But I can't say my students, all my students, has such kind of com shape. No, we still miss one thing of the com. What is that? AI. Even my student, the Indonesian PhD student, he's still not good at AI. And this is why I'm here to ask for your help. If you are good at AI and interested in such kind of software, hardware, co-design, please contact me. Okay, we can go further. Happily together, hopefully. Okay, never give up. Why? The final job is, God's open the door for you. No worries. At least you got the door. Okay, so why I'm here? Because I have such kind of mini UN lab from Indonesian to Czech, and Ukraine, India. Okay, so if you're happy to join us, we can have research cooperation or even lab intern. The students go to my university, go to my lab, or vice versa. Everything, everywhere is welcome. Okay, thank you. Now, hopefully, it will be the beginning of the beginning for the cooperation between my university and your university.
I think we have 5 minutes for questions. Any questions?
Just wanna make a comment.
Yes,
Please, we have to leave, but
Yeah.
I was at the beginning excited, but after you describe how miserable it is.
Miserable at our side. It's happiness at your side. No worries.
And then I also noticed that all the students were foreigners, you didn't show the locals.
Okay. Very good recommendation. Yeah.
Thank you. Thanks a lot.
Thank you.
Jose, are we all going to?
I actually cannot make it today because I have a previous engagement.
Okay.
But you're all welcome to go.
Okay.
And I just speaker.
Okay, all right.
Thank you all.
Questions? Yes.
Yeah, I had a question, a kind of dumb question, but like, so the video you were showing with the student, with the student using like a hardware description language or something to monitor with the FPGA or how does that work?
Oh, I can show the coding, the script for FPGA. For FPGA design, usually my student use very long, if I'm right.
Okay.
Yeah. But what I showed you, that is related to SPICE.
Oh, like circuit.
Yeah, circuit simulator. Yeah, anyway, for very long, actually, it is good not only for FPGA but also for digital IC design. Digital IC design.
Oh,
Yeah, to for example, if you would like to design RISC-V, something like that, you need to know how to do Verilog coding. Yeah, yeah. Thank you for the question. Yeah, well, please.
How far do you think you're away from achieving your dream?
It's hard to say. If there's some right person, I mean, good at AI and would like to get some domain knowledge from our side, maybe 1 year will be good enough. But it's hard to find. For AI guys, they have very happy lives. Just like Jose said, they wouldn't like to touch our miserable life. It's the key problem. Yeah, please.
EMSC,
TSMC.
well,
Yeah,
the big one.
yeah.
Are they planning on moving a lot of fabrication to the United States?
Yeah, of course.
Okay.
Yeah, because King Donald Trump says.
Yes.
Okay.
Well, how long will that take?
Oh, actually, I think for a new fab, it will take maybe two years at least. Because it is not efficient to construct the new fab here. On the country in Taiwan or in Japan, we can make it maybe 50% off. Yeah, we're hardworking guys.
Well, can you find the workers? Once it comes to the United States, how, do you have to bring workers from Taiwan or?
So of course,
Oh.
yeah, because American workers here, if I'm right, they almost nobody would like to take night shift. So we need to hire somebody out of USA to become 9 hours. Yeah. The pay, again, that is maybe some kind of national secret. Yeah. I guess your local workers here, they still make more than our poor Taiwanese or the other any kind of foreign workers in Phoenix. Yeah. So you can see, without foreign workers, I don't think TSMC fab will run smoothly. No, that is no way.
So, would it be more than 50% foreign workers or?
I have no idea.
Okay.
Yeah, because you have a very strong worker union, right? There's a lot about this. So I guess it is regulated by your government. TSMC has no way, has no right to make the decision. But it would like to negotiate with your government. Yeah.
Well, if the union issues decrease, we still need a lot of foreign workers?
Maybe that is, maybe the answer maybe is yes and no.
There were a lot of people in this country that worked in the semiconductor industry before TSMC kind of took over the world. I don't know, maybe a lot of them have gotten old enough that they're not going to jump back into it, but I mean, there is expertise, and there are people working in that field, but there just aren't that many fabs in the US anymore.
You still have some.
That's some, but it's.
Yeah, just like Intel, right? Intel
Yeah.
has a few very good labs, luxury labs.
What's it, fabs?
Yeah, so yeah. But again, your workers wouldn't like to take night shift.
I think a lot of them did work 24-hour shifts.
Yeah, of course. I visited onsemi in Czech Republic. The senior managers, they told us, oh, don't get any kind of misunderstanding. We check, work as hard as you Taiwanese, no worries. But I need to point out that they have 4 shifts. In Taiwan, we have only 3. They are still, their life is still better than ours, please.
The thing I don't understand is you said your timeline from starting the 70s with Professor Pong and all this jazz.
Uh-huh.
And
you know, you're working on this dream of automating these processes and you're doing scripting and all this stuff. Why is it taking so long? And we're in 2025, there's so many other examples out there in industry, and I'll just take cars, for example. Things have been automated. Why is this so hard to crack, or why is it taking so long? It's not making sense to me that it's only now that you're, you know, in 2025, they're trying to solve this problem. This doesn't make any sense.
I don't think I'm the right one to answer this question, but I try my very best. If I'm right, there are simply too many parameters to be optimized automatically. Actually, TSMC, UMC, Intel, Samsung, they apply AI to enhance the yield long time ago. But even till now, AI cannot replace all the manufacturing engineers. If I'm right, they are, I can say, millions of parameters, but I think they're very close to, very hard to fine tune.
You had another slide where it talked about not all parameters are specific, just like a global set. It would seem to me would work on automating kind of those initial parameters, or what lack of a better term, the things that are always static, because you know they don't change. Because I think I saw a slide that you said some portion of that was, it's a rinse and repeat, and then all that other fine tuning required more expertise. I don't know what that ratio is, but it would seem to me you could at least automate that portion first. And if that took n number of people, you obviously just improve by whatever that is, versus trying to do it end to end, which is what I was kind of seeing what you were trying to do.
I think they already make it partially, but they cannot make it fully. Otherwise, TSMC won't be able to dominate the whole global market.
Seems like a great thing for a competitor to do and overtake them, and you can solve this problem.
Yeah. So you can see, if you work for Intel, definitely you will make more money, much more money than TSMC employees. Why? The yield is so poor. I mean, compared to TSMC. Maybe even the employees, the engineers for Samsung, they still make more money. Yeah. But the outcome is not as good as TSMC. So again, that is a solid proof. We are poor Taiwanese. Don't complain.
If you make less money, then you have less money for rent and things like that. Is there a problem?
How do we say that?
No, I think Taiwan, I was in Taiwan in January. I think life is good.
Because the how can I say, the living the living expense is much lower than here. Yeah. So
To be back at like 30 something.
yeah.
Food, clothes.
So for young guys, don't get any kind of misunderstanding. If you cooperate with us, you will have some kind of miserable life in the future. No. You still stay here to make US dollars instead of Taiwanese dollars. Like
Spend US dollars.
anyway, if you get
We make money and then move to Taiwan.
that is the good choice. To work for American company, stay in Taiwan, it's not right.
So it's a.
The problem with moving to Taiwan for Americans is health insurance.
Health insurance is the best.
I think so, yeah. We provide the maybe the cheapest public health insurance system on earth. If I'm right, in Obama's era, yeah, some of the medical doctors here, they tried to copy and paste our system.
have some illness, they fly back to Taiwan.
Oh,
Yeah.
yeah. Yeah,
So it's
to spoil our healthcare system.
seriously, yeah. They provide, even if you don't have insurance, if you have an emergency, you go in there, they cover it.
Yes. So anyway, we try our very best to help not only local people, but international humankind.
Oh, for tourists, how's that work? How's that help?
As I'm saying, if you get sick, you're traveling there, they cover.
Oh, I need to highlight that.
Yeah.
Even though you don't get any kind of health insurance in Taiwan, I mean the public one, but you pay totally by yourself.
Yeah.
I promise you, much cheaper.
Cheaper,
Maybe
for sure.
all this cheaper than here. But our medical students, our medical doctors, they are as good as yours. No worries. Because my daughter is one of them. So she would like to join America, but that is really troublesome. So she gives up. Yeah. Anyway, for young students, yeah. Especially for young students, please do visit us to see it to believe.
We're still recording.
Ah,
You probably want to stop recording.
please help me too. Whenever I say something about him, it should say. Might not be able to come back. Yeah, I would like to make them, I would like to get in USA. The other room. What the key you told about? What do you mean?
YouTube, the whole lecture.
Yeah, anyway, I would like to get in trouble, but again, to see is to believe, to visit us. Never mind, to go touring, to exchange. See,
So who are you actually talking to here in the university to try and get this collaboration? Are you talking to Zoe? Have you met the president?
No, he's talking to me at this point.
You're the POC.
not only.
Oh.
Yeah. Similar slide.
For this department, for this university.
Yeah, of course. Anyway, anyhow, I was invited by many of the international universities. Never mind who they are, yeah, where they locate. I only try my very best to promote that kind of international cooperation. Yeah, you can see, I'm not kidding. I'm a very passionate guy for my own country, but we wouldn't like to make any trouble especially for USA. No, USA help us to defend ourselves, please.
But back up, go ahead.
Yeah.
Do you use, since you use MATLAB, do you use Simulink heavily?
In the past, yes, but right now, no. Please.
What's a Python, what, you're saying you had like a Python thing, what is it interfacing like under the hood?
Come on, that is the dirty job for my students, not for me. Okay, yeah.
Okay.
So if you are interested, I will be more than glad to hook you up with my PhD student. Yeah, he studied here, so his English is much better than mine. You won't have any kind of trouble to communicate with him.
Well, all right, so maybe give another round of applause.
Thank you.